Hello students, how are you all? Till now we discussed numericals based on combination of resistor and basic information about EMF of a cell and internal resistance. We did solve so many numericals based on the topics. Today we are going to solve numericals based on cells in series and in parallel. So let me start with question number 81. A battery consists of a variable n number of identical cells which are having internal resistance R each and are connected in series combination. Okay, in series combination of cells. Okay, look at this. This is how n identical cells are connected in series. And they said the terminals of the battery are shorted. Okay, the meaning of shorted is there is no load resistor. These are just connected with a straight line. There is no potential drop across the terminal voltage. So they said all these are identical cell. That means E and R. E is EMF, R is internal resistance. This is how many such type of cells are there? N cells. 1, 2, N cells. Whenever cells are connected in series, the equivalent voltage is going to be E equivalent, as all these cells are connected in series aiding, then total EMF of all these cells is going to be N times of E. Similarly, as all these resistors are connected in series, total equivalent resistance is going to be N times of R. Then current flowing through the circuit is I is equal to V by R, right? So it's going to be E equivalent divided by R equivalent. E equivalent is N times of E. R equivalent is N times of R. N will get cancelled out. Then I is equal to E by R. The question they are asking is we have to draw the graph between I and N, where N is N number of identical cells. Does this equation depends on N? No, it is not. It is independent of N. It means whatever it may be the number of cells which are connected in series, it does not matter because current is independent of number of cells. If it is independent of number of cells, then I am going to get a straight line. Just observe here. This is the straight line I am going to get, because even though you are changing the value of number of cells, the value of current is not going to change. It is going to remain constant. That's the meaning of this graph. So this is N and this is I. Which option matches for this? Option A is the correct answer. So for question number 81, option A is correct. So let's just check out. Let's move on to the next question. 82. Let me read it out. 10 identical cells connected in series are needed to heat a wire of length 1 meter and radius R by 10 degrees Celsius in T time. So similar to the question number 81, they are connecting the cells in series. So EMF of the cell is going to be increases by n number of times. So here, how many cells are connected in series? 10 cells. Then what is going to be equivalent to voltage? E equivalent is going to be 10E. Similarly, equivalent resistance is going to be NR. Okay, let it be. How many cells will be required to heat the wire of length 2 meter and of same radius by the same temperature? Super. Observe this. Did they give any information about internal resistance of these cells? No, they didn't give any information about internal resistance. You just assume it is as 0. Internal resistance of all these cells is 0. So a wire is used. This EMF, all these EMFs are used to heat a wire of length L so which is of 1 meter and radius r. Okay, so let's say resistance of this wire r is equal to rho l by a, where l is 1 meter, then area is pi r square. This is the resistance of this wire. Now they're using n number of cells, then it is going to be ne. They didn't said what is that number n. They're asking how many number of cells will be required to heat the wire of length 2 meter. Now here length of the wire is 2 meter. Let's say this is r1 and this is r2. It's going to be rho into 2 meter divided by radius of same radius. Okay, say at same temperature they're asking. So same radius in the sense pi r square. This is the resistance of the second wire. So we have to heat it, the second wire also, to the same temperature. First wire is heated by 10 degrees Celsius in T time. This is also heated to the same temperature and in the same time. Then we know that heat energy formula. Heat is equal to, general formula is V square by R into T, right? So let's write down equation for both of them. H1 is equal to is V1 square. H1 is directly proportional to V and R, right? Because here T is the same or different? T is the same. And one more thing that we have to understand is this heat is replaced by ms delta T, isn't it? Just observe here, what's the general formula for mass? So mass is equal to density into volume, right? This is how we can replace. Volume is length into area of cross section. Is this how we have to replace it? Let's say this is m1. Then what about m2? M2 is equal to, density does not change, length is 2l, radius remains the same. That's why it is going to be. So can I write down m2 is equal to 2 times of m1? Yes, we can write down like this. Okay, so here heat formula can be replaced as mc delta T, whereas m is mass, c is specific heat capacity, delta T is the change in temperature for the first wire and for the second wire. We are heating those two wires to the same temperature change in a same given interval of time. So we can use, you just can equate these two. Let me write down equation 1 for the first case. For the first case, it is m1c delta T is equal to V square is 10e whole square divided by R1 into T. Similarly, m2c delta T, which is equal to ne whole square divided by R2 into T. So let's say this is equation 1 and equation 2. Try to divide these two equations. C delta T will get cancelled out. T also will get cancelled out. E square by E square also gets cancelled out. Now I am left with m1 by m2 is equal to 10 square divided by n square into R2 by R1. Just observe here what is the relation between R2 and R1. R2 can be replaced as 2 times of R1, right? R2 is 2 times of R1 and M2 is 2 times of M1. Then M1 by M2 is 1 by 2, which is equal to 10 square by N square into R2 by R1 is 2 by 1. Then from this n square is equal to 4 into 10 square. Then n is equal to 2 into 10, which is equal to 20. So 20 number of cells must be connected in series. Which option? Option A is the correct answer for question number 82. Understood? Let's move on to the next question. Two cells having the same EMF are connected in series through an external resistance capital R. Okay, so let me draw the circuit. They said only those two cells are having same EMF. They didn't talk about internal resistance. It means they given information also. Cells have internal resistances R1 and R2, and that too R1 is greater than R2 respectively. Okay, let me draw that circuit. This is how circuit is going to be. Though EMF is the same for both the cells, but their internal resistance is different. Let's say this is E and E, R1, R2. This is the load resistor, that is also called as external resistor here. When the circuit is closed, the potential difference across the first cell is 0. Okay, right now circuit is closed. If the circuit is closed, try to find out current flowing through the circuits. Let me calculate. This is as I. Sorry, it's not from load resistor, it is from the batteries, that is I. As these two cells are connected in series, it's going to be I is equal to E equivalent divided by R equivalent. E equivalent divided by R equivalent. What is E equivalent here? 2E. What about R equivalent? R1 plus R2 plus capital R. This is the value of current flowing through the circuit when it is closed with the help of external resistor. Now the condition is, and the hint also, potential difference across the first cell is 0. This is the hint. The question that we have to find out is external resistor. Try to understand, every question includes hint and the question that we have to find out. Okay, here they said potential difference across first cell is equal to 0. Instead of before going to decide how total voltage across cell is going to be 0, let me find out what is the EMF of the what is the terminal voltage of the first cell. This is how current is flowing in anti-clockwise direction. Let's say here it is entering plus minus, here it is entering plus minus, and here it is entering plus minus. Just observe these two cells. These two cells looks like as if they are connected in series aiding or opposing. There looks like they are connected in series opposing. Then what's going to be voltage across first cell? Voltage across to first cell is going to be E minus I into R1. That's going to be the voltage across the first cell, which is equal to 0. That's the hint they have given. Okay, so let me substitute this. This is E minus I value. So 2E divided by R1 plus R2 plus capital R into R1, which is equal to 0. So E will get cancelled out, right? Because you just send any one of these to right side, then it is going to be written as like this. This E will get cancelled out. Then it's going to be R1 plus R2 plus capital R is equal to 2 times of R1. Then R is equal to, send this R1 right side, it's going to be R1 minus R2. Which option matches? Option B is the correct answer for 83. Okay, understood? Next, question number 84. Two batteries, one of the EMF 18 volts and internal resistance 2 ohm, and the other of EMF 12 volts and internal resistance 1 ohm are connected as shown. Oh, the given circuit also. The question they are asking is voltmeter reading. Let me draw the circuit first. I'll give you two different methods to answer this question. They are asking what's the voltmeter reading. Earlier I told you about voltmeter. What is the internal resistance of voltmeter? It's always infinity. Ideal voltmeter internal resistance is infinity. They didn't mention whether it is, they didn't give any internal resistance of voltmeter. That means it is ideal in voltmeter only. So it represents internal resistance of that voltmeter is infinity. Will any current flows through that voltmeter? No, right? So that is the reason I just removed that circuit, voltmeter. Now if you just observe this one, these two cells looks like as if they are connected in series. Let's say this is minus plus minus plus. minus plus and plus minus. These two cells looks like as if they are connected in series aiding or series opposing. They looks like as if they are connected in series opposing. Then what's going to be resultant voltage? Resultant voltage is going to be 6 volts. Just observe here. So hope you are able to understand. The circuit you can replace like this. Understand, guys? So this is how the circuit will be. So remaining two terminals I just can remove them. So it looks like this. So these two cells looks like as if they are connected in series opposing. So total voltage is going to be 6 volts. Okay. In opposing we have to subtract them, 6 volts. So what is the total resistance in this series circuit? 3 ohm. Then what's going to be current flowing through the circuit? I is equal to V by R, where V is 6 volts divided by 3, which is equal to 2 ampere. From what is the direction of current flowing through the circuit here? Current always flows from positive terminal to negative terminal, but as we have two EMFs here, we have to select which EMF I have to follow. In the sense, whatever the EMF which is of high potential, that's the potential that I have to prefer. Here 18 volts is of high potential, so current flows from the high potential. So this is the direction of current flow. What is the current flowing through it? It is 2 ampere. So here it will enters and leaves. 2 2s are 4 volts. Now observe these two cells. These two cells looks like as if they are connected in series aiding or opposing. Series opposing. Then what's going to be voltmeter reading? Voltmeter reading is equal to 18 minus 4, which is equal to 14 volt. That's the answer. Which option? Option D is the correct answer. This is one way of answering. I'd like to give another method by using equivalent voltage formula. So whenever two cells are connected in parallel with of different internal resistance and with a different EMF, so we have a direct formula to find out EMF, equivalent EMF of those two cells which are connected in parallel. Formula is E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. Sir, do we have only formula to find out equivalent EMF itself? No, we have a formula to find out R equivalent also. So how R equivalent can be calculated? So that is 1 by R equivalent is equal to 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus and so on, whatever it may be the number of cells. So you just have to write it down like this. So E1 is 18 divided by R1 is 2 plus E2 is 12 divided by 1 by 1 by R1 plus 1 by R2. R2 is 1 here. So it's going to be 9 plus 12, 21 divided by 1 by 2 plus 1 is 3 by 2. 3 by 2. So 3 7s and it is going to be 14 volts. Yes, I got the answer. This is another method to find out voltage, equivalent voltage or equivalent EMF of different cells which are connected in parallel. Got it? Let's move on to the next question. Question number 85. Two identical batteries, each of EMF 2 volts, internal resistance 1 ohm, are used to produce heat in an external resistance. External resistance is R, by passing current through it. Okay, so this is how current will flows. The maximum power that can be developed across R is, first of all, try to find out equivalent EMF and internal resistance of this combination. So let's talk about this. As these two cells are connected in series, then equivalent voltage is going to be 4 volt and resistance is 2 ohm. So this is capital R. For the maximum power, we have a condition for maximum power flowing through the condition. For the maximum power to be dissipated in the circuit, internal resistance must be equal to external resistance, that is equal to capital R. That means internal resistance here it is 2, which can be equated to capital R. So formula for maximum power is going to be V square by R equivalent. This formula is used to find out what is the total power dissipated in the circuit. This is not the case, but the condition they are asking is power dissipated in the load resistor. That means I said for maximum power I have given a condition for maximum power internal resistance must be equal to external resistance. Then first of all find out the current. So this R also equal to 2. Let me find out current. Current I is equal to 1 ampere, right? Because 4 volts divided by 4 ohms. Then voltage power dissipated by external resistance R is equal to I square R, where I square is 1 into R is 2. So answer is 2 watts. Which option matches? Option B is the correct answer. Understood? Okay, let's move on to the next question, number 86. Hope you are following. So two batteries of EMF 4 volts and 8 volts with internal resistance 1 ohm and 2 ohm are connected in a circuit with resistance 9 ohm in the figure. The current and potential difference between 2 points P and Q are, okay. Potential difference between P and Q is nothing but potential difference between load resistor, right? So let me draw that circuit. This is the circuit they have given. First of all, we have to decide these two cells are connected in series aiding or opposing. So definitely they are connected in series opposing. As 8 volts is greater than 4 volts, we have to subtract this potential. At the same time, we have to follow the direction of 8 volt. So the direction of current is going to be from 8 volt battery, that is from 8 volts EMF only. So resultant voltage can be replaced like this, which is equal to 4 volt plus minus. I must follow the direction of higher potential. This is how current will flow through the circuit. So let's find out what's the value of current. I is equal to E equivalent divided by R equivalent, right? What is E equivalent? 4. What's R equivalent? It's going to be 12. 9 plus 1 plus 2. It's going to be 12. So answer is going to be 1 by 3 ampere. So by this itself we can decide which option is correct. Option A itself is correct. So but we have to answer remaining also, because that is the only option which matches current as 1 by 3 amperes. What's the current flowing through the circuit? 1 by 3 amperes. So here it is entering plus minus. That's it. They're asking what is the voltage across points P and Q. Voltage across points P and Q is nothing but voltage across the load resistor, right? So voltage across the load resistor is nothing but a terminal voltage, which is equal to I into R. I value is 1 by 3, R is 9 ohm, which is equal to 3 volts. That's the answer. Got it? So let's move on to the another topic, Kirchhoff's laws. Next topic is Kirchhoff's laws. So in Kirchhoff's laws we have two types. One is KVL and KCL. KVL is Kirchhoff's voltage law. That is, algebraic sum of voltages in a closed loop must be equal to 0. Understand this line. Algebraic sum of voltages in a closed loop. So this point is important because we have to find out voltages in a closed loop. Whatever it may be the type of element, doesn't matter. So you have to find out all the voltages in a closed loop. So sum of all these voltages in a closed loop must be equal to 0. And this KVL is based on law of conservation of energy. Next one is algebraic sum of, it's KCL, Kirchhoff's current law. Algebraic sum of currents entering at the junction are equal to 0. entering at the junction or leaving at instead of this we can replace this point as algebraic sum of the currents at the junction are equal to 0. Same point I have given here. Sum of the currents entering at the junction are equal to sum of the currents leaving at the junction. And KCL is based on conservation of charge. So these are the basic points to understand. Let's move on to the numericals. Question number 87. The potential difference between the points A and B in the given circuit is. Just observe the circuit. This is the circuit that they have given. VA and VB are given as shown, and the question they are asking is VA minus VB. That means VA must be greater than VB. So whenever you come across these kind of circuits, you just have to replace this circuit like this, as this is positive, so it's going to be positive, negative. This is VA, remaining it is negative, positive, and here it is battery is replaced like this, minus plus. This is VB. Now let's use KVL. You can start with from any battery. Let me start with VA. So that is minus VA plus 4 plus 3 plus 2 plus VB, which is equal to 0. If you observe one thing, I'm just selecting first sign of all the elements. Minus VA plus 4 volt plus 3 volt plus 2 volt and plus VB. So that's the process I just selected. You can choose second element also, but one thing you have to select. If I am choosing first sign of the first any element, then you have to choose first sign of all the elements. If I am selecting second sign, you have to go ahead with the second sign of all the elements. That's the procedure you have to follow. Okay, now finally they're asking VA minus VB, right? So VA minus VB is equal to, send VA right side, VB also right side. It's going to be 9 volts, right? Which option? Plus 9 volts or minus 9 volts? Plus 9 volts. That's the answer. Understood? As I told you earlier, you can select second sign also. Let's say this is plus. Then I have to consider second sign of all the elements. Second sign, second sign, second sign. How can you decide second sign or first sign? So you have to observe along the path in which you are taking this loop. This is how. As I am moving like this, I am selecting first sign or second sign. It depends upon myself. I can choose anything. So second sign here it is minus. So let me use this and let me write down that equation. So VA second sign is minus 4 volt, minus 3 volt, minus 2 volts, minus VB, which is equal to 0. So this is equal to minus 9. Then VA minus VB is equal to, send that minus 9 towards right, it's going to be plus 9 volt. Again same answer. You can choose any direction, that's your wish, but only thing you have to be clear that which sign you are choosing. Okay, understood? Let's solve next question. Question number 88. In the circuit shown, the cells A and B have negligible resistance. For VA is equal to 12 volts. This is 12 volts. VB, did they mention? No, they didn't give any information. What's R1? R1 is 500 ohm and R is 100 ohm. Okay. Galvanometer shows no deflection. The meaning of galvanometer shows no deflection. There is no current flowing through that circuit. That's the meaning of that. So you can remove that galvanometer. If galvanometer is showing no deflection, in the sense Ig is equal to 0, right? Okay. What's the question they're asking? The value of VB. They're asking potential VB. If you observe one thing here, this VB and R both are connected in parallel, right? Then voltage across R is the same as VB because they are connected in parallel. So I'm going to replace this like this. Just observe this one. Okay. We just can replace this circuit. Here it is. So whatever the voltage that you are going to get across resistor R, that's going to be voltage VB. Okay, so this is plus minus. Now if you observe, these two resistors looks like as if they are connected in series. Then what's going to be total current flowing through it? Current flowing through the circuit is I is equal to equivalent voltage is 12 volts, 12 by R equivalent. R equivalent is 600 ohm, which is equal to 2 by 100 ampere. Okay, this is the current flowing through the circuit. So this current flows through this R resistor also I, and voltage across that resistor capital R is same as voltage VB, which is equal to I into R, where I is 2 by 100 and R is 100, which is equal to 2 volts. Which option? Option B is the correct one. This is one way. So there is another way to answer this kind of question by using voltage division method. As these two cells resistors are looks like they are connected in series, we can apply voltage division method. Then VB is equal to total voltage into, we have to select the resistor across which we are finding potential, that is 100 divided by total resistance in the circuit 500 plus 100, which is equal to 12 into 100 divided by 600. This 100 will get cancelled out. 2 volt is the answer. This is the another way to answer this kind of question. Got it? Let's solve question number 89. In the circuit shown in the figure, if the potential at point A is taken to be 0, the potential at point B is. These kind of questions you can answer directly by selecting the circuit itself. At two different points, right? They're asking us to find out potential at a single point. 2 points in the sense, another point is given as a reference. That another point is A, whose potential is taken to be 0. So in the circuit given below, I just took part of the circuit. Now I'm going to find out voltage at point B. Whenever they are asking at a particular point what is the voltage, then this is the way to answer it. Only thing you have to do is just select 2 points and just ground them. So this is the another point that I am choosing, just grounding it. As I said earlier, instead of grounding, we can use another method, that is connect a battery which is of potential like this. Let's make it as positive, plus minus VA, and another one is connected like this. Yes, you can choose the circuit like this, minus plus. If they are asking potential at any particular point, this is the way to answer. Okay, then you can choose a path. So let me select this loop and you can use KVL. Let's start with VA, minus VA, minus what's that, this potential, this is 1 volt, minus plus. I chose first sign, so this is plus minus 1 into 2, it's going to be 2 ohm, right? And it voltage is 2 volt, so it's going to be minus VA minus 1 minus 2 volts plus 2, this is plus minus, then plus VB, which is equal to 0. They said VA is 0, that is given in the question itself. This plus 2 minus 2 will get cancelled. Then VB is equal to plus 1 volt. That's all. That's the way. Which option? Option A is the correct answer. Just check out this once again. Go through it again and again so that it will be clear for you. Let's solve next question. Question number 90 is a theoretical question. Kirchhoff's junction law follows from the conservation of charge. Yes, it is correct. Kirchhoff's loop law follows from the conservation of energy. Both are correct. Option A and option D. KVL is based on conservation of energy. KCL is based on conservation of charge. Both are correct one. Let's solve question number 91. They're asking which of the following equations is correct. Okay, so let's imagine this is loop 1 and this is as loop 2. Okay, in loop 1 and loop 2, let's apply KVL. Loop 1 and this is loop 2. Let's apply KVL and let's cross check whether any option matches or not. Let's observe loop 2 first. Observe this circuit. I just divided loop 1 and loop 2. It doesn't mean that I'm just make it as an open circuit. It is not the meaning of this division. I'm just it is easy for me to write down KVL equations. That's the only purpose. Here at this junction, I1 and I2 both are entering. Then total current is going to be I1 plus I2. And voltage across this resistor is I1 plus I2 into R. And here I2 is leaving and I1 is entering at here. Resistor is R1 and voltage across plus minus voltage across it is I1 into R1 is the voltage. Okay, let's apply KVL for loop 1. You can start from anywhere. Let's say this is E1, right? Minus E1 plus I1 plus I2 into R. Next plus I1 R1 is equal to 0. This is one equation from loop 1. Let's try for equation in loop 2. So current is entering here plus minus voltage is I times of I1 R1. Here it is current entering plus minus I R2. You can start from anywhere as I told earlier. KVL is minus E1. I'm starting from there. Minus E1 minus I R2 I2 R2 I2 R2 plus E2 plus I1 R1 is equal to 0. Which option matches? Here we go. So this one can be replaced as equation E1 minus of I1 plus I2 into R plus minus I1 R1 is equal to 0. Equation 1 matches perfectly. That is option D is the correct answer. Next question, Kirchhoff's first and second laws of electrical circuits are consequence of. So what is first law? First law is KCL and second law is KVL, right? First law is based on conservation of charge. Second law is based on conservation of voltage. Which option matches? For question number, write you to option C is correct. First law is KCL, second law is KVL. First law is based on conservation of charge, second law is based on conservation of energy. Next question number 93. Kirchhoff's first law is summation I is equal to 0 at the junction. Deals with the conservation of charge. Option C is the correct answer. Understood? Our next topic is based on Wheatstone Bridge. Just let me read it out this question. Question number 94. The resistances of 4 ohms P, Q, R and S in a Wheatstone bridge are 10 ohm, 30 ohm, 30 ohm and 90 ohm respectively. The EMF and internal resistance of cell are 7 volt and 5 ohm respectively. If galvanometer resistance is 50 ohm, the current drawn from this cell they are asking. Okay, super. They are not asking what is the current flowing through the galvanometer. They are asking what is the current drawn from the cell. This is what they are asking. That's what I have to find out. Before going to solve numericals based on Wheatstone bridge, we have to cross check whether it is a balanced bridge or unbalanced bridge. How can we cross check whether it is balanced or unbalanced bridge? So the thing is, if product of opposite resistances are equal, then the bridge is going to be balanced. Just observe here. So these two, 10 into 90, it's 900, and these two, 30 into 30, 900. So that is the meaning here. So we know the balancing condition. So what's the balancing condition? P by Q is equal to R by, right? R by S. Balancing condition. Balancing condition is P by Q is equal to R by S. So this one I can replace it as P into S is equal to Q into R, right? That's what I told. The product of opposite resistors must be equal in balancing case. If it is equal like this, then what's the use? Current flowing through the galvanometer is going to be 0. If current flowing through the galvanometer is 0, we just can remove this galvanometer. So as it is a balanced bridge, I just cross checked already. So 10 into 90 will give you 900, 30 into 30, 900. Product of opposite resistance is equal here. So current flowing through the galvanometer is 0, so that we can remove that galvanometer, because current flowing through it is 0, right? No need to consider that. Now this is the remaining circuit. These two resistors looks like as if they are connected in series. Next, these two are connected in series. So this combination will give us 40 ohms, and this combination will give us 120 ohm. This 120 ohm and 40 ohm, these two are connected in parallel. So let's replace this circuit. What's the resultant of parallel combination of 40 and 120? So it's going to be 40 and into 120 divided by 40 plus 120, which is 160. 40 ones are 40, 4s are 430. Okay, 430 is going to be 120. That's how we can find out equivalent resistance. Now the remaining circuit can be replaced as shown. Here it is. So 7 volts, 5 ohms internal resistance, external resistance is 30. Now I have to find out current I from this cell. I is equal to V by R. V is 7, R is 35, which is equal to 7 ones are 7 5s are 1 by 5. Then I is equal to 0.2 amperes. That's the current. For question number 94, which option? Option D is the correct answer. Understood? Very good. So let's move on to the next question. Let's move on to the next question. 3 resistors PQ are each of 2 ohms. Okay, 2 ohms, 2 ohms, and 2 ohm. And an unknown resistance S from the 4 ohms of a Wheatstone bridge circuit. Okay, so another unknown resistance is S. Okay. When a resistance of 6 ohms is connected in parallel to S, the bridge is balanced. When a resistance of 6 ohms is connected parallel to S, then the bridge is going to be balanced. Then what is the value of S? What's the meaning of bridge balanced? Current flowing through the galvanometer is 0. When current flowing through the galvanometer will be 0? If product of the opposite resistance is equal, then current flowing through the galvanometer will be 0. So let's find out product of the opposite resistance. Product of the opposite resistance in the sense here it is P into S into 6 divided by S plus 6. That's the equivalent resistance of these two, which is equal to R into Q. So where P is 2 ohms into 6 into S divided by S plus 6, which is equal to R into Q is 4. 2 2s are, then 6S is equal to 2S plus 12, which is 4s is equal to 12, then s is equal to 3 ohms. Which option? Option A is the correct answer. Understood? Very good. Let's solve question number 96. In the circuit shown, if the conducting wire is connected between points A and B, the current in this wire will be, there is a condition. So if P by Q ratio is greater than R by S, then current flows from A to B. If P by Q ratio is less than R by S, then current flows from B to A. This is the basic condition for a Wheatstone bridge. Just let's check out whether this ratio is the same or not. So that means this is P, Q, R and S. Let's cross check this ratio. P by Q is 4 by 4, 1. R by S is 1 by 3. 1 is less than 1 by 3 or greater than 1 by 3. It's greater than 1 by 3, right? So if it is greater than 1 by 3, for just check out this relation here. I think I wrote in opposite. This ratio is opposite. P by Q is less than R by S, then current flows from A to B. If it is greater than, P by Q is greater than R by S, then current flows from B to A. Say here, if you observe the ratio, P by Q is 1 by 1, which is 1, greater than R by S, R is 1 and S is 3. Yes, it is following this rule. So in this case, current flows from B to A or A to B. It flows from B to A. There are several other methods also, but this is the easiest way to answer how current flows. It based on the ratio P by Q and R by S ratio, we can answer this. Okay, let's move on to the next question. Whenever you come across this kind of questions, you just have to cross check whether bridge is balanced or not. Just what is the multiplication of these two? Opposite resistor only. This 3 and 4. 4 3s are 12. And what about this 6 and 2? 12. So as product of opposite resistance is equal, then you can remove this resistor, that is 4 ohms can be eliminated. So remaining circuit looks like this. So this is how circuit looks. This is how it is. So what is the question they're asking? This is 6 ohm and 3 ohm, 4 ohm, 2 ohm. Question they're asking, current flowing through the circuit, right? So these two resistors now connected in series. These two are connected in series. Remaining combination is connected in parallel. Okay, so let's find out those. So this series combination will give you 6 ohm and this series combination will give you 9 ohm. Parallel combination is 6 into 9 divided by 15, which is equal to 3 2s are 3 5s are 18 divided by 5. I need current flowing through the circuit. Then what is the total voltage? V. And I is equal to V by R. Question they're asking I itself. Then I is equal to V by, what is R equivalent here? R equivalent is 18 divided by 5. So final answer I is equal to 5V divided by 18. So which option matches for question number 97? Option D is the correct answer. So next let's solve question number 98. This question number 98 I am going to replace like this. Just observe the circuit. Guys, just observe the circuit. How did I replace it? I just removed this part. I just adjust it to here. I just flip it. Just open that circuit. So observe this network. Just removed or open that circuit. That's all. and I'm observing over there. Now the question they're asking is, a battery of V volts is connected between A and B. Okay, so total voltage is V connected between A and B. So this is how the battery can be replaced. Understand? Okay, so what's the potential that they are giving? V volts. Okay, this is connected between A and B. This is how it is connected. Okay. Now the question they are asking is the current flowing from AFCEB. Okay, what is AFCEB? This is AFCEB. This is the current they are asking. Okay, first of all, let's cross check whether it is going to be balanced Wheatstone bridge or unbalanced Wheatstone bridge. As opposite resistors, all of them are same. Product of opposite resistance is going to be definitely equal. So it's R into R square, R into R square. Then it's going to be equal. So product of opposite resistance is same. So you can remove a middle resistor, right? So you can remove this. Now, if you observe here, these two resistors are connected in series. Resultant resistance is 2R. These two resistors also connected in series. Resultant resistance is 2R. Now if you observe, this voltage, total voltage V is connected parallel to these two combination, right? Then I can replace it like this. Voltage across these two is V itself. I need current flowing through it. Then I is equal to, I know total voltage is V and total resistance is 2R. That's the value of current flowing through AFCEB. Which option? Option C is the correct answer. Understood? Very good. So let's move on to the next question. In a Wheatstone bridge, all the 4 arms have equal resistance R. If the resistance of galvanometer arm is also R, the equivalent resistance of the combination seen by the battery. As they said, all the 4 arms are of equal resistance. So is that going to be balanced or unbalanced bridge? That's going to be a balanced bridge. Do I have to consider galvanometer resistance? No need to consider. The only thing is I need equivalent resistance seen by the battery. So this is where battery is connected. So it's going to be internal resistance and EMF. Equivalent resistance seen by the battery in the sense. This is what I have to find out. This is what the resistance is seen by that battery. So this is R. So these two connected in series, resultant is 2R. These two are connected in series, resultant is 2R. These two connected in parallel, resultant R equivalent is going to be R itself. So that is what the equivalent resistance is seen by the, what do you call, battery. So option C is the correct answer for question number 99. Let's move on to the next question. Question number 100. The resistance of each arm of a Wheatstone bridge is 10 ohm. A resistance of 10 ohm is connected in series with the galvanometer. Then the equivalent resistance across the battery. So same process. They are asking equivalent resistance across the battery. Same process. In 99 question, 100th question, both are same. Only in place of R, they are substituting 10 ohm. So the resistance of each arm of the Wheatstone bridge is 10 ohm in question number 100. In 99 it is R. So what's going to be R equivalent as seen by the battery, which is equal to R itself, and that is 10 ohm. Question number 99 and 100 both are same. So option A is the correct answer for this question. Okay, understood? So let's solve question number 101 solution. First thing you have to do is you have to cross check whether it is going to be a balanced bridge or unbalanced bridge. They're asking the net resistance of the circuit between A and B. Just observe here, those 3 8s are 24, 4 6 are 24. So yes, it is a balanced bridge. Product of opposite resistance is same. So you can remove this middle resistor. So the circuit can be replaced like this. Okay, so this is how it is arranged. So which is 3 ohm, 4 ohm, 6 ohm and 8 ohm, A, and this is B. These two resistors are connected in series, which is 7 ohm. These two are connected in series, which is 14 ohm. These two resistors connected in parallel, and resultant is going to be 7 into, let me write it down here. Equivalent resistance between A and B terminals, A and B, is 7 into 14 divided by 7 plus 14, which is equal to 21. So answer is going to be 14 by 3 ohm. Which option? Option B is the correct answer for question number 101. Now question number 102 solution. If you observe question number 102 and question number 98, both are similar, but in this case they are asking equivalent resistance. As I said earlier, you can replace the circuit like this. This is the combination that you can replace. This is how you can replace the circuit. So all of them are of 2 ohms, 2 ohms, 2 ohms, 2 ohms, 2 ohms. I need resistance between A and B terminals, right? So as I said earlier, here product of opposite resistance is going to be same. Then you can remove that, and if you remove it, these two resistors looks like they are connected in series. Resultant is 4 ohm. These two are connected in series, resultant 4 ohm. Now these two combination is connected in parallel. Resultant is going to be 4 connected in parallel. 4 into 4 by 4 plus 4, which is equal to 2 ohm. Which option matches? Option D is the correct answer for question number 102. Understood? So hope you are understanding and follow this series perfectly and practice as hard as possible and try to revise it as many number of times as possible, because immediately by seeing you are not going to get this kind of ideas. By repeated practice only you are going to get this kind of ideas. All the very best, guys. Thank you for watching. Have a nice day.